Welcome again. Today I'm going to present, as in title, Build Data Pipeline with Snowpark. It's a topic mainly big data related, but it can be also applied for data engineering or data scientist. And a brief introduction about myself. I'm a big data engineer from Ingrid Dynamics from 2018. I'm mainly skilled in streaming, Snowflake, event-driven architectures, Java, Scala, and Python. As other activities, I'm also senior specialization lead for Poland, and I'm mainly responsible for big data engineers in our country. Here we have the agenda. I will give a brief overview about what Snowflake is, what is Snowpark, how Snowpark logging and monitor and can be monitored, a possible deployment methods, and then a demo about Snowpark using Scala. Let's start with Snowflake overview. For who is not familiar with Snowflake, Snowflake is an SaaS with also a data storage process engine that can be used for fast and easy to use analytical solutions. Good thing about Snowflake is that it's not based on any big data technologies or other data platforms, and combine the really big skills of SQL engines that most of the people are aware of with a brand new innovative architecture. So Snowflake is cloud ready. So everything is compatible with Azure, Google Cloud, AWS, and so on, and is based mainly on 3 levels. So the application level, that is the cloud service, the query processing, that is based on virtual warehouses that are also considered like nodes. And these nodes are responsible for fetching the data from our storages to have them in an intermediate level that is called also cache, and to process the queries that are sent via the client. Here we can see the clients that are always already present for Snowflake. We can recognize mainly known as Spark, Kafka, but also Tableau. It can be interfaced with the common ODBC, Python, and Java technologies as well, JVM technologies. And here on the left, we have Snowpark. Why Snowpark is considered a client for Snowflake? Snowpark is available right now in Scala and Java, but as a feature release, there will be Python as well. Right now, in order to interface with Python, you need a simple Snowflake connector. So you need to build your own query as a string and send it via driver. So SQL-based platform. As I said, this is expectations of Snowflake because everything in Snowflake is SQL-based. So everybody think that it's a simple, a common DBMS. Most of the people choose it because SQL is easy for everyone, and it's easy to understand. So let's say that is human readable. It's transactional, so you can perform all possible CRUD operations that are daily used, such insert, update, delete, or create tables, views, and so on. And some clients choose Snowflake because, like also Spark, just to mention, some moved to SQL from the first versions of it. So why not to consider everything as a SQL? But let's say this is our reality. You can see that we have this query that is divided in 3 parts. This query was really complex, and most of us during the activity tried to make it more simple as possible, but this was the easiest solution. So that was our reaction. So this query is impossible to understand. And this is the answer we got. So this is actually the other side of the coin. How can the store procedure be debugged? This behavior is not present as a built-in function, not like simple UDF. How can I integrate my app with it? Maybe you have an Android application that use a specific framework, or you have a brand new integration framework or product that is not yet ready for it. This is one of the best that I also got several times, but on MS SQL worked in this way, the query, why here not? And some more detailed cases, like this column need to be decrypted using some client library. So you can have some specific encryption function that is especially for who is interfacing with the migration from legacy systems, maybe even written with the really old products, and they want to move to Snowflake. They need to have some external jars that perform this encryption decryption, or you want to use some other ciphering algorithms and so on. And the other one is, how can we make our CI/CD on such logic? We can use some tools like Flyway, we can use some other stuff, but the integration within that require a lot of effort, or people that have really strong skills in it. And here it comes Snowpark. Why it comes as a solution? Because, as I say, Snowpark is an application, so it's a client for Snowflake. So here there are some mentions about Snowpark. I'm not going to read them, but mainly Snowpark is considered, like, as it's written here, a new developer experience that use, for who is familiar with big data tools, the same approach as Spark. So this data frame style where you can put functional code or functions like select, from, and where. Snowflake is, as also Spark data frames, lesser evaluated. So in this case, everything that you're performing on your Snowpark application is not executed in memory. It's not executed on your server or on your local laptop. Snowpark will build the functions that then will be executed on the server. This, as I've written here, reduce a lot the amount of data that you're transferring from the client to the server. So these are some examples of integration with tables. We can see a simple read. So session table, we have one sample, and the select. So some built-in functions like upper or lower than are already provided by Snowflake. And also it considers star, as you are doing with the general queries. The insert is performed with two different ways, append and overwrite. So in this case, we are creating a data frame from a Scala sequence. Snowpark already understand case classes. So here we are going to make a case class that has 2 strings and 1 double. And this will be understood by Snowflake. And based on the type of the case class, we'll create the SQL type. So in this case, we will have string type, double type, and the full case class will be translated to a record. Passing to the save mode, as I said, append and overwrite. Append, check if the table exists, and in case it's not, it creates it. And if the table exists, perform an insert of the data frame. So you will have an insert with all the columns defined based on your data frame and the values that are fetched from the lazy evaluation of the data frame on the server. And at the end, you just define where. The update works more or less as we would do with the normal SQL. So as we can see here, we get, first of all, the information about which table we would like to update. And the assignment here, the assignment is based on immutable map. So we are passing here the column name we want to update, and as a value, the value that we want to put when the condition, that in this case is a column, a data frame column, is respected. So in this case, we want to know if the size in square meters is greater than 10. 10 as a literal value. Delete works in the same way as update. So we provide, again, a criteria that will be translated to where condition and table that we'll get for the metadata. This also is another feature that Snowflake by default provide as a SQL function, but is also supported in Snowpark. So in this case, we define two data frames, our source and our target. And our source, in this case, I will go deeper on that in the next chapters, but is created from a user-defined table function. So we generate an arbitrary records, 10,000 records, and the merge works as a following. So we say that our target is the destination, so as I said, and we want to merge it with our source. And the following part says the criteria of it. So we want to check that the substring, so the first two characters on the left side, are the same as on the other side. So source equals destination. When not match, we insert the full record. When not match, we update the size square meters. So it will be translated with like, when not match, insert, when match, update the record in the target. And at the end, we are printing, in this case, how many rows have been inserted and how many rows have been updated. So next chapter is the integration with streams. For who is familiar with the change data capture approach, the stream is created on a table and is based on checkpoints. So it tracks from the last committed transactions all the operations that have been performed on a Snowflake table, and create a subset of it that can be read by another client to perform some, for example, incremental load or some event-driven operations. So here we have CRUD operations on our table A. And this table, all these operations that commit will be fetched by our stream and will be available. Here we can see that the stream will, if you do a select star on the stream, you will have the all columns from the table A plus 3 artificial columns that will be used from our client. How can it be used? Let's say you want to track all the new records that come in your stream, and for every record you want to perform a logic. In this case, you go to check the metadata action if it's insert. Then the update is considered like an insert, but with a flag as true or false, depending on the operation. And the row ID. So this one is the first row ID not yet read from the Snowflake table. Same thing is for delete. It takes the row ID of the first unread record from the stream, from the table, and will be used as a subset. But how can be used in SnowSQL? So using legacy SQL. A stream, as indicating here, advances only when there is an ADML that uses the transaction. This behavior applies to both explicit and not auto-commit. Querying a stream without performing any commit will not change the offset. So let's say a scenario. We have the stream A that we created before, and we want to perform a DML to write in the table B, such, for example, insert into from the stream. At the end of this transaction, there will be a commit. But what happens if I want to use the same subset for another operation? In this case, as we can see from the red arrow, it will not work because the first transaction commit. So after this, the stream will not contain the same subset processed by the first. How can it be solved? Let's say that you have one transaction with multiple operations. This is how it will be translated with Snowpark. We put, in this case, everything in the try catch block. We mark the auto-commit as false, because by default, until version 1.3 of Snowpark, auto-commit is set to true. So we force it to false. We open a transaction in this moment, and we perform our operations, append, and then if everything succeeds, we commit, otherwise we roll back. Let's go to the second, next topic, UDF and UDTFs. UDTFs were mentioned before, but as I said, I'm going deep now. So UDF, also known as user-defined function, accept a row as an input. So it can be a set of columns or the full row, and return one output for each input. The return consists, as I said, on a single column. What is the difference with UDTFs? UDTFs generate a set of multiple rows. So you can have 0, 1, or n for each input. Like in the previous sample, I was just passing the number of arbitrary records I want to create, and the user-defined table function return the same amount of records as the parameter I sent. So how can it be used without Snowpark? So using legacy NoSQL. With Snowpark, without Snowpark, creation, deployment, and usage happen in different isolated stage in charge of the developer. So they are created and persisted on the server. It means that if you need to update the user-defined function or the user-defined table function, you need to drop the previous one or replace the previous one in order to have the new one. And they are located in the Snowflake backend, and you need to be authorized to create and to use it. What it changed with Snowpark? The creation is a Scala function. So Snowpark provides you the command for creating and for publishing the UDF. And after that, everything is managed by Snowpark without any effort. So here, as I said, deployment, it's directly managed by that. There is no developer that needs to go there, make the query to deploy the user-defined function. And there is also this other feature that is related to temporary. So let's say that our application runs once and then goes down. Like we want to say we are orchestrating an application that is triggered every day, performed operation, and then will be triggered once again the day after. In this case, the user-defined function is just published it once, used it, and then dropped. Okay, let's go with examples. As I said, the creation of a user-defined function is a simple Scala function. So you define 0 to n parameters. and one return value. In this case, I used a function that I needed in my use case and was not present as functions provided already by Snowflake. What this one does, I need to get two columns that are array types, and I want to make a union, but excluding the duplicates. Easy operation if you work with the JVM. You just use set from one side and set to the other side. And then you make a concatenation and return the value. But how can you use it? We have a simple example. Two values, A and B, and I create the array. At the end, I want to union it with A and C. So with column, distinct code, and the value will be, here I put the example of the two ways of invoking the UDF. One is directly as reference. So when you perform this operation, register temporary, the function returns a UDF instance that can be used in this way as the first row in the sequence. Or since you assign a name to the UDF, you can also call the built-in function call UDF, defining the name and which columns are our parameters. And this is the result. As you can see, union code and union by name are exactly with the same results. Let's pass to UDTFs. UDTFs are considered class, not function. Why? Because for the UDTFs, you need to define different override method. One is the execution itself. So what the function will do after when you're invoking it. What is the schema of it? Why you need to know the schema? Because as I said, the user-defined table function generates a record. So you need to tell Snowflake how the record should look like. So let's say in this case, we have string, and another alphanumeric value. And then here I created, in my case, one function that converted to the type row. What is a row? Row is an array of values of any type that will be then sent to Snowflake. And Snowflake will understand the type of it using the output schema. Last but not least method is the end partition. I forgot to mention before that Snowflake, even if it looks like a data warehouse platform, works like most of the big data tools. So it partitions the table, partitions the rows, and they are also replicated within the partition in the data nodes. So in this case, the UDTFs generate the records, but also the records are distributed. So we need to tell, in this case, when and how the partition is considered as complete. So in this case, the partition is closed when we have no following records. And as we have done for the UDF, you register it, giving it a name and the class instance. How this is managed from the Snowflake side? The class is packed in a jar and sent to the Snowflake server, where there are already all the dependencies that are needed in order to compile and execute the Java function. The way of calling it is like the UDF, but in this case, the return value is not a column, but is a table. So in this case, we call simple show command to show our values. And here we can see the result. This can be really useful when you need to create something on the fly. And this is not a result of a query, but it's a result of your custom code. Let's say we want to perform a performance test of our query. So we can make this table function that is generating tons of records And then after that, we want to perform our query. In this case, the table function is really useful. So working with file and stages. As I mentioned at the beginning, Snowflake can be also used as data storage because it's being cloud ready. It can be connected with our blob storages like Amazon S3, Azure Data Lake Storage, and Google Cloud Storage. But if you use SnowSQL and you want to put the new file in the stage, so in our storage that Snowflake provide, you need, let's say, if you want to upload it from your local laptop, you need to interface it with Snowflake client because you need to authenticate, you need to be authorized to do that, and then to upload. Or if you want to use external blob storage, you need to allow Snowflake to read and write from the storage account to create a stage on it and then to read. Or another case, we need to publish the file based on an ingestion job, such, for example, Azure Data Factory pipeline or Talent job or an enterprise service bus pipeline, whatever. In this case, you need to still to authenticate that service account and to write to Snowflake stage. Another point, this file is just a file for Snowflake. So you need to create a file format in order to translate this file in a table type. It means that for every type of file, you need to create a file format for it. How this can translate it with an easier way using Snowpark. First of all, you can directly stage from your VM. So it means that you can apply less network traffic if you consider it with the blob storage. And we all know that if you are in the cloud, every network traffic outside this, the cluster itself land in a cost. Also, you don't know where the application stays. And if there is some internet outage or so on, you have to consider the IO operations. So in this case, if you have already your application that is connected directly with your Snowflake stage, the network traffic, so the network is already established and the IO operation is really quick. So other point, as I said, the VM can be connected to Snowflake. So it means that if you have an Android application, a JVM application, or whatever, it can be easily interfaced with that. Other point, single point of authentication. What it means? It means that if you have a JVM that can perform everything, the JVM is authenticated. You already know that if you need to give a new grant on the application, you are not going to give it to users or to users group. You are going to give it to an automatic system, so our JVM. Other point that is related to the creation of file formats. Snowpark already provide built-in functions that allow you to read JSONs, Parquet, CSVs directly as built-in. So you don't have to create the file format. Snowpark will take care of it. You just need to pass some optional parameters if you need to apply some specific parsing. So let's go for some example. Here we have how to create the stage. Create a stage is a one-time operation. So Snowpark does not give you the possibility to some pragmatical approach for it, but it allows you to execute queries directly as a string. Here is how we stage the file. So let's say that we have the file on our file system. In this case, a simple put file giving where the file is located on our local stage, in our local file system, and where we want to put it, using some options. For example, compress, not compress, and so on. And at the end, you get the result of it. Why you need to know the result? Because the staging of the file is asynchronous. So in this case, you need to know when the file has been staged. and you can get it from this operation. So this put result can be run several times until the status is succeed. How to read? As I said, Snowflake provide already the operation for it that are built in. So you don't have to create file format. If you just say, I know that I'm going to read a JSON without any specific parameters. It's just simple JSON. I want to have it in my data frame. One line of code. And then when we perform the parse JSON, it will be translated to an object. So it will be easy to browse through and to read what is inside. So in this case, we see column body, that was the body of our JSON, and the sub attribute, such as name or surname, and so on. All right, let's pass to logging and monitoring. So about alerting. Yes, Snowflake provides a lot of a rich catalog of table views that allow you to monitor the status of your warehouse, the query, if it's like stuck or is running for a long time, or if somebody perform an alter and so on. Yes, it does. Login system, same story. You can see the history of the queries, the histories of the DDLs, histories of interactions, by whom, how long it took, the cost of the query, because being Snowflake cloud, also Snowflake applies some pricing on it. So you can see everything from these views. But what if we want to have an alerting on email for some events, or if we want to have an alerting if the query is taking a long time based on, and to send it, for example, on Slack or on Teams. In this case, you need to anyway use an external tools that query this catalog of tables and views and then perform the alert. With Snowpark, no, because Snowpark already provide, being a JVM, can cover these problems like system for metrics are not human readable. In this case, from SnowSQL, because how can I understand how much is useful for me to know the credit spent for this information if I just want to have an alerting? And as I said, there are no built-in notification systems. For example, if we want to have an alert if a Snowflake task failed to run, we need to create an on failure callback. Let's say that we are in Azure, that trigger an Azure function, and this Azure function will send us the notification. Same for AWS, you can use Lambdas. Login system. Let's say that we want to use these tables and views. Yes, you can, but only high-level roles can read these views. For example, account admin. Audits are per database. But what if I want to have one login system for all my ecosystem? And then to divide it per database on my side. In this case, with Snowflake, you cannot, with NoSQL, you cannot have it. Other point, I want to have my login system in Datadog or in New Relic or Azure Monitor and so on, Grafana. In this case, you need to have, as I mentioned, an external product that is interfaced with both sides and publish it to them. And here it comes Snowpark, alerting. Being a dedicated application, there are already a lot of products that can already do it. For example, with Java and Scala, we have email connectors, but the same with Python. Python, Java, Scala have already built in integrations with New Relic, Prometheus, Azure Monitor, and Datadog. Also, being a custom application, you can make even your own one. Centralized login system. Log4j, Logback are just the two examples. And these two frameworks, these two libraries, are already integrated with in-file logging, external blob storage. So you want to log directly on your Google Cloud Storage or on your S3, Log4j, Logback, or other frameworks have already the implementation for it. Or let's say that I want to make my login system based on Apache Kafka or on some event-driven products. Log4j, Logback, and other products have it. Snowflake does not. SQL. And as I said, Snowpark already has as a dependency Log4j or Logback. You just need to switch between them, whoever fit more your needs. Okay, let's pass to deployment, because the framework can look good, but it has to be productionable. So it can be placed, let's say, literally everywhere where you can deploy an application. So it can be on cloud, but can be on premise, can be on your local laptop, can be on your Raspberry Pi, whatever. And it's fully compatible already with Databricks notebooks, Amazon Lambda, Azure Function, Jupyter Notebooks, or a simple jar, for example, if you want to put it on your on-premise server. And being Dockerizable, it can be placed as Docker image or Kubernetes. All right, time for questions. Any?
I do have a question. Can you hear me?
Yes, I can.
It's about the end partition method in UDTFS.
Yeah.
I'm not exactly sure what it does. I mean, it returns some kind of iterator, right?
No, it's an array. It returns an array that indicates the latest part of the partition.
So like a tail of a partition kind.
Exactly.
Okay, I see now, thanks.
Okay, I can see. Is it Snowpark free or come with some cost? No, Snowpark is free. It's available also as a Maven dependency or SBT dependency, whoever you want to use. For right now for JVM technologies. Later will be performed also as egg file or wheel in case of Python. But the only cost you need to deal with is the cost of the Snowflake instance. Hi, Alex. Yeah, I can answer your questions now. So one is, as I see, Snowpark is Spark integrated with Snowflake. Not really. So it used the same, yeah, maybe with less built-in functions as the Spark data frames, but just for writing the queries. But under the hood does not use any Spark or other distributed frameworks. It used the data frame structure because it's more known for, especially for who works with already with, for example, Spark or PySpark or Pandas for some degrees. And after that, when you send it to the server, it gets translated to query, and the query is executed on the Snowflake side. So it's Snowflake that then execute the query, make their own plan and using their own optimization. About the second, can we load files from S3 to Snowflake tables, or it doesn't make sense? No, it really does, because on S3, you have unstructured data or semi-structured data, and maybe you need to do some analysis on that. In this case, it's really useful to have them in a more tabular format. So in this case, you can perform your operations using the SQL-based approach. So yeah, as I said, that with Snowpark does not exclude the fact that you may need these files on cloud, but on the same way as you can read the file from the local system and stage them to the Snowflake side, you can directly work with the stage created on the Google Cloud or on the Azure DLS or Amazon S3. So once the file is in the stage, that can come from the local file system, the local storage that Snowflake provide, or the external one, you can interface with Snowpark. So after that, you can read on the Snowflake UI, let's say, or with SnowSQL directly, or you can make your own query, your own logic using Snowpark, but interfacing with the external storage. Because on Snowpark level, you're not going to download any file. You're building the query that then will interface with the client. All right, so let's go to the second part of our meetup. So in the demo, we'll show mainly the 4 points. So how to perform simple CRUD operation, an example of merge operation, and how to deal with streams. And then later I will show a full pipeline using a DAG approach. Okay, I'm going to move to my IDE. Okay, so let's start with the sample CRUD operation. So here we create our Snowpark session. How the Snowpark session is created? I decided here in my case to apply a singleton, atomical singleton operation on Snowflake session, and to check if the connection dropped for any reason. For example, a session got dropped for network and so on, the Snowpark internally will create a new one. You need to pass connection properties that are map in this case, and I can show in this case how the properties are created. So I'm not going to share my YML file, but simply I have YML containing all my username, URL to connect, password, warehouse, database, and schema. These two are optional. You can also avoid them if, for example, your application is going to interface with several databases or several schemas. So in this case, you can set up the database or the schema at the query level. Once the session is created, work similar like as Spark session. So you can, based on that, create your data frame. So for our case, for insert, I use the table function that I was talking about before. I want to drop the duplicates for the district code. And in this case, I'm doing an overwrite in the table industry code. And I will do the same for another table, but in this case, instead of generate my arbitrary records, to read from the already created table, apply a where condition. So let's say our district's code starts with L or with D, and to write in industry code L or D. Perform update is another example. So I want to, as assignment, I want to put size in square meters equals as itself times 1000, where the district code starts with D. Where? In our L or D, because in our L or D, we have all the industry codes that start with these letters. Here we can see that starts with is a built-in function from Snowpark, same as lower. Then the delete. So as I was explaining, you put here the condition that will be translated to a column. And this column will be translated to the Snowflake expression where size in square meters greater than 100. The other example is the merge. So what we are doing here, I generate again industries using my table function. I get my source industry code. Here, I assuming that the table already exists. I will show in the second part of the demo how to deal right now with the case where the table does not exist. And we apply the merge. So we want to merge with the source where district code, so the substring of the district code from the both sides, source and destination, are the same. When not match, we insert all the fields with the related value. Otherwise, we update. We put the district code all in upper, and we multiply the size in square meters for 100. But let's go to execute it. Okay, it's going to compile. And here we go. So session is getting created. All the informations about our session are created here, including client and so on. And at this point, as we can see, our user-defined table function is getting deployed. So it gets deserialized, serialized and sent to the server that will be then responsible for deserialize again, and to use it. And here is our function. So this is how the function is translated and populated to the server. Then all our functions are executed, and we can go to our Snowflake instance. We run show tables, and we can see industry code and industry code L or D. So here we have our industry code. L or D. As you can see, everything here is present with department code, with district code, and size in square meters. Okay, so let's go now to see how everything gets logged. So here we have the execution of our table. And at the end, we have a hook that will close the sessions, canceling all the queries. Let's go to see how it's performed the query itself. So let's search for valid session present is what I said. And here, regarding the question that Bart made, the partition, the iterator is generated later on the Snowflake side. All right, so let's go now to see everything from the pipeline standpoint. And how we are going to perform it. So let's go with streams now. Stream for the Snowpark side works in the same way as table. So here I have another example, another project. And in our stream, what we do? Let's go from main. So we again, since it's another application, we go to generate our user-defined table functions, generate industries, and in this case, we have generate employees. So these two table functions are generated here, and after that, they go to, let's go here, and we trigger our pipeline. So here we can see that the Snowflake plan contains the translation to the query. We are creating a temporary function that returns a table. And then, as we can see, it logs everything, but it can be set up on the log4j level. And after that, we are going to perform the real inserts. So this is an example where we go in append, create a table if not exists, and then insert. If we want to go in overwrite, it will be translated to create table as. So in this case, it will recreate completely the table with the result, with the value that we have in our source. So here we create the stream. The stream we pass stream name, object name, and with replace. As I said before, the stream, like also the stage, are one time created. So it is not a result of a query. It's a single command. So in this case, I created my own function that build the query, accepting with the replace, if not exist, show initial role as are parameters that you pass in the creation. And at the end, we execute the query. And then after that, we generate our records using the user-defined table function, invoking table function, generate industries. And the same is for employees. And then we write from stream to table. So stream name and table name are in this case strings. And the way how I get the last status from the stream is just, as I said, treating it as a table. This is translated to select star from. And then I apply my query on it. So this select and so on is then append as a query on top. So in this case, this select substring, and this will be performed as select column A, column B, column C, column D from select star from this one. It may look not readable if you write it directly on NoSQL, but it performs the same optimizations as you would write select column A, B, C, and D from direct the table. Is from Snowflake plan is exactly the same. But then let's go with joins. So the Snowflake stream, yes, perform a change data capture approach, but it doesn't mean that you cannot join. Because in this case, everything is happening on the transaction. So we have our employee that is based on the table employee, and the second data frame is based on a stream. So we are kind of doing a lookup on the employee using all incoming records from the stream. And then at the end, we go in append. Let's see how it looks like. We come back to our Snowflake side. We do again show tables, and we have our examples. So let's go with select star from employee. And this is how it gets created after our table function. And let's go with now getting the stream. So industry code first 2, for example. And at the end, we can go, for example, let's take from demo data pipelines, industry code stream, industry code stream. And why we have no records here? Because the transaction happened in order to write to industry employee. That is employee industry. Let's say right now we have no match because, as I said, there were arbitrary records. So it doesn't mean that we find for sure some match. But we can try, for example, to retrigger it once again. And we can, in this case, increase the number. So let's go with 10,000 from one side and 10,000 from the other side. And we run it. Okay. We come back here. Let's see if this time we match something. Yeah, as we can see, we have now name, surname of the employee, and in which district code it match. All right, let's go to the last part of our presentation. And we go with the full pipeline. So here we have 4 REST endpoints: restaurants, ratings, orders, and payments. And these restaurants land in our local path. We stage them, and the same thing will be with payments. Regarding rating and orders, we directly get the JSON as API as an API response, and we save it in a table that will contain the raw format of our rating. The same will be for order. On top of them, we are going to create restaurant dimension. This restaurant dimension is every time refreshed with the last status from the restaurants. The rating get read from a stream. So we always get, as I say, the subset, and we write to transactional rating. Same thing will be for order. And for payments, we are going to perform a different approach. Instead of read directly from the stage, we are going to create a stream on top of the stage. What it means? It means that I will not read the same file more than once. And then I will write to tran payment. Then tran order and tran payment will have on top of them a stream we are going to present best rating restaurants within 30 days. This will be a Snowflake view. Then we are going to have a data quality check, for example, payment, where the order, the payment was more than the order price. And then at the end, an order paid with American Express with the rating greater than 50. What I mean with the rating greater than 50, that the rating of the restaurant where the payment with American Express has been performed received a rating more than 50%. Okay, let's put it in action. How I emulated this as 10 points, I created a web application using Scala TRA. And on top of that, I made REST interfaces that will return an array of JSON. Based on that, as I mentioned, everything will be performed iteratively every minute using a DAG. This DAG is a custom implementation. In my case, was taken from one library that I made time ago that will perform nodes and children. So in this case, I'm making a direct acyclic graph where the first thing is to ingest payment, rating, order, and restaurant. And then on top of that, to make all the logic on top. So let's analyze them one by one. As I said about restaurant, we pass session and the parameters. In this case, how many records I want to get from my REST endpoint. Then I made all my configurations in a YML file. And then after performing the REST call, I stage the result from my local file system. And executing in transaction the operation, I read the JSON that is present in my stage. I explode it. Sorry, I parse it. I explode it. And then I override the table. This JSON array to explode field is something I want to spend some time on. Being Scala, I created an implicit class on top of data frame, adding the new functionality where passing a JSON that is within one column, so a JSON array, I explode the array applying the flatten function from Snowflake. And then I call JSON to field, where in JSON to field, I take the attribute name and I put it as a field. Then the same thing, we go from ingest payment, but in this case, as I said, there was a stream on top. So we have, again, stage. So we create a stage payment. We create a stream on top of the stage. We stage the new file. We wait for the stream to get refreshed because it needs some time. And after that, I fetch all the new incoming files that are in the stream. And then again, I explode them and I write to payment. Regarding order and ratings, they follow the same approach. So I will show only one of it. And in this case, what we do is we perform our HTTP call. We get the JSON as a string, and I'm creating the data frame directly with the value that I have already as a response. So I'm not going to stage anything. I'm not going to use their storage. I want to directly perform it from my side. And I make a single column table that is called, in this case, rating row, with only one column response. And every time I go in append on it. So after that, we have the stream, and the stream is red. And in this case, I don't need to to parse the JSON. I just get it because it's already as a table format. I just explode it directly on Snowflake. What it means that in this case, the data is already present there, and the query will land in a really fast time. And last point, order and rating may have some duplicate. So in this case, I'm going to perform merge operation. As I mentioned before, Snowflake does not handle right now during the merge, the table exists or not, because otherwise you cannot perform the compare operation. So what I do in this case is I try to get my table. Then if exists, I perform a merge. If it does not, I perform a write. So let's say that is the first time that we create it. And I'm delegating Snowflake to create the query, to create the table. How? Using the schema that I'm already giving to it. The same thing will be done with the order. And then we have here the data quality check. So order paid more than price. We create a stream on our payments table. We create a stream on order table. And then, as I said, in transaction, because I don't want to write something if then one record fails. And I want to commit only at the end. So in this case, I take the two streams, and I'm going to take the total amount that was for that order, because it can happen that the number of payments that perform for the same order can be more, like you are having a dinner with friends and we want to split the payment. And then I take order, I join with the payments, and I write to my DQ table. Top restaurant. This one is, I take my rating data frame, and I check that the rating day is between today and 30 days ago using built-in functions from Snowflake. And then I do a group by restaurant code, and I check my rating percentage in average. At the end, this time, as I said, I'm not going to create a table, but I will create or replace a view. So in this case, the Snowflake plan, instead of be translated to an insert or to a create or replace, will be translated to create view. Last but not least is our paid with Amex. So this one lands in a little bit more complex structure, because we take first all the payments with Amex, then all the ratings that have more than 50, then all the restaurants that have payments. So I'm going to take orders, join payments, orders will be joined with restaurant, and the restaurant will be joined with rating. And at the end, I'm going to perform or an insert, once again, if the table does not exist, or a merge operation if the table exists. Okay. How the DAG will work. So here I have my root node. This root node is just a placeholder for starting my DAG. And I made the first four children that are the first four operations I indicate. And all of them are parents of DQ, paid with Amex, and top restaurant. Okay, let's run it. I make it as continuous, so every time the full pipeline is executed, it will wait 1 minute before executing it once again. So everything is running. Our web service is returning responses. As you can see, Snowflake perform the log of all the operation. So refreshing the stage and give you the examples. Create the file formats, read the files. Going to rating, and order stream is successfully created. Okay. Trump payment didn't get refresh. Let's go in the meantime to our Snowflake site. And we do again show tables. So you can see now all our tables are getting created. Our pipeline finished. So let's go to select star from, for example, run order. We have our orders, or we do it with rating, same thing, or we do it with run payment. Here we go. But let's go to our tail of the pipeline. So here you can see all the streams we created, all the stages, and let's go with the first one. So I want to see the best rating restaurants. Not yet created because there were not ratings higher than 50%. Then we can wait until the pipeline is still refreshing. And let's go to analyze, for example, select star from order Amex. Let's see if this one contains some data. Here we go. We have the first one that has been generated from the previous. So we have an order paid with Amex where the restaurant code is AB272 and the rating was 64. Let's check our last one of the tail. So select star from DQ payment. And here we can see tot price $61, but tot paid was 98, 2026. You can see we have several records that match this criteria. So let's see now if we have restaurant with good rating. Yes, we are. And coming back to our function, to our pipeline, here is continuing to run. So now it's refreshing the restaurants. It's performing again all the operations. And the good point is all these UDTFs right now are not going to be redeployed every time because I am within the same session. So in this case, I'm just saying to the pipeline, continuously generate records, but in this case, all the file formats, all the table functions or UDFs are still present there. They're not tiered down. All right. So as we said, we analyzed our pipeline, completed successfully. Do you have any questions? Okay, we deploy Snowpark app to AKS or EC2 as ordinary standalone batch streaming app, right? Yes. You can, it's a jar. So it's a single jar. It can, and you can interface with that however you want. There is also a nice new feature from Snowflake where your Snowpark application can be deployed as a store procedure. So in this case, you don't need to deploy the application. You can just take the jar and publish it as a store procedure for Snowflake and giving the name. So in that case, you can just do call the store procedure, and the store procedure is translated as Snowpark application. They publish it the end of March. All right, so seems that we are perfectly in time. Thank you once again for joining the meetup from today, and have a nice rest of the day. Thank you all. Bye-bye.